Hi, good morning. My name is Ghina Saber, and today I'm going to talk about plastic and its impact on society. Agenda. I'm going to talk about monomers, polymers, polymerization process, product of plastic, evolution of plastic, advantages and disadvantages of plastic, decomposition of plastic, plastic impact on the environment, and in the end we have the summary. So first, what are monomers? Monomers are atoms or small molecules that bond to form a complex structure. Alkenes, vinyl chloride, adipic acid, and glycol act as monomers, and they are used to create a polymer.
Also, based on my research, some places says that amino acid and sugar are monomers, while others says that they aren't monomers. So I'm not sure, but I just in case mentioned them because we know that amino acid makes up protein in our bodies, so it kind of acts as a monomer.
And then we have polymers. Polymers are composed of large molecules called macromolecules, and they are the result of the bond of monomers. And it is the complex structure of the monomers. It makes up many of the substances in living organisms, between brackets, organic things. And a polymer has a high molecular weight. And now we move to polymerization. Polymerization is the process of making a polymer, and it's usually used in making different types of plastic. Monomers bond together to make a polymer. Different ways of polymerization have special kinds of polymers.
And in the process of polymerization, we need pressure and high temperature.
And here in the figure, I'm having a table. It shows the monomers and the polymers. And we can see that ethylene is converted to polyethylene. And poly means many, it's like many of ethylene.
Or like many of a molecule, many of a substance.
And the same thing for propylene. It's converted to polypropylene. And the list goes on. And now we move to the production of plastic. Plastic is made out of raw materials that get refined into ethane and propane, which they are from the alkane family. And raw materials could be as steel, oil, gasoline, natural gas, coal, and so on. And then it gets treated with heat in a process called cracking to convert them into ethylene and propylene, which are monomers. And the process of cracking is literally means breaking down, which means you have a huge molecule, then you're gonna take it and break it down or split it into two pieces, two molecules, and then you will have ethylene and propylene. And then you combine these monomers with catalyst, which is an activator, to form a polymer called fluff, and it looks like the powder used for laundry. And then the polymers are fed into an extruder to get melted and shaped into a pipe shape.
And it's not always a pipe shape, it depends on the shape that you put it in the extruder.
And after it cools down, they cut it and use it. And this process is only for thermal plastic. And thermal plastic is the kind of plastic that melts quickly, like the plastic used for the water bottles. And over here you can see 4 molecules. The first one is propane from the alkane family. You can see 3 carbons
connected with each other by single covalent bond.
And then in the second structure, you can see ethane. 2 carbons bonding with a single covalent bond. While in the third structure, you can see propene or propylene. You have 3 carbons, but 2 of the carbons are bonding with double covalent bond. Same thing for the fourth structure. You have ethene or ethylene bonding together with a double covalent bond.
And that's what makes up the difference between the family of alkane and alkene, where the alkane have 1 single covalent bond while the alkene have double covalent bond. And this also makes the difference in the structure of the material.
And here in this figure, you can see thermoplastic and thermosetting plastic. And this is its structure. You can see that thermoplastic, each monomer
bonds with 2 monomers,
while thermosetting, you have for each monomer bonds with 4 other monomers.
And that's what makes up the difference between them. And that's why thermosetting plastic is stronger than thermoplastic. And makes thermoplastic melt faster than thermosetting plastic.
Because the polymer chain in the thermoplastic isn't really connected and linked together, which makes it melt faster and make the polymers break down faster and easier. While in thermosetting, the connection between the polymers are strong and makes the plastic stable. And due to this difference, we can see why thermosetting plastic is more used for things that would last for a long time, as gas and water pipelines, pan handles, electrical plugs, and kitchen appliances. And even though they are made from the same monomers, they are different in the structure. And we can see this example by graphite and diamond. Both of them are made of carbon, but the structure of graphite is weaker than the structure of diamond. And that's because graphite have 3 bonds with each carbon, while diamond have 4 bonds. Over here you have the figure of the extruder. Here is the hooper. You put the raw material in it, and then the burr and the screw mix and rotate the plastic or the powder, and the heater over here works to activate it
and to shape it,
and then it moves
until it reaches the cooling part,
and then over here it goes out in the shape that you want, like as a pipe or the shape that you selected, and put it in the extruder so the plastic could come out as the shape of it. And then we move to the evolution of plastic. On 1873, John Hyatt
combined solid nitrocellulose,
camphor and alcohol under pressure, and it was the first synthetic plastic. While on 1907, Leo Baekeland made the first synthetic plastic that doesn't contain organic materials. And in 1926, Waldo Simon made plasticized polyvinyl chloride, or PVC, that is used for construction, plumbing, and other industries. And in 1933, chemists found solid polyethylene by accident, and now it's the most used plastic. On 1955, disposable plastic syringe was found. And in 1965, Swedish company found plastic bags made of polyethylene. On 1969, they expanded PTFE to have EPTFE, or expanded polytetrafluoroethylene, which is a strong, waterproof, and breathable material. And it's also used for electronics, cars, winter boots. And then you have their structure. First you have polyethylene, which is C2H4. And over here, you can see that it's not the full molecule because it's a huge molecule. So they put the molecule between the brackets and then multiply the molecule with the number of the rest of the molecule. And then you have PVC, which is C2H3Cl. And the same thing over here, it's a huge molecule, so they write N and outside of the brackets to then multiply it by the rest of the molecule. And in the end, we have EPTFE, which is C2F4, and outside you have N. And then we move to the advantages and disadvantages of plastic. First, we're going to begin with the advantages. 1. Low cost. It's cheap. 2. Water resistance. 3. Lightweight. 4. Durability. 5. Flexibility. While the disadvantages are pollution, long decomposition time, and it's dangerous to the wildlife, might cause cancer, and it has a higher cost of recycling. And then we have the composition of plastic. And you have multiple types of decomposition, as photodegradation, which is decomposition by light or ultraviolet light, and it includes physical and chemical changes. And then you have thermo-oxidative degradation, where a plastic decomposes by heat and oxidation, and both has different effects on plastic. And then you have hydrolytic degradation, which is decomposition by water, where polymers react with water and break up. And then biodegradation, which is decomposition by microorganisms, where they break down the polymers, and the time of the decomposition depends on the material used for the plastic. Plastic takes a long time to decompose, and sometimes it doesn't decompose. So scientists found a new solution for it, which is the usage of biopolymers or biodegradable polymers. And then we move to plastic's impact on the environment. The first and mainly impact on the environment is pollution, and there is multiple results for pollution on the environment, as restriction of movement for animals, issues in the digestive system, issues in reproduction, prevent from breathing, and injuries.
It doesn't only affect the animals, it also affects the humans. Let's take the cutting board as an example. There's some cutting boards that they are made of plastic. Sometimes after you cut the vegetables or your food on them, some particles of plastic comes into your food, and this causes some problems in your digestive system and in your body.
And in the end, we have the summary. Plastic is a polymer. It needs a lot of time to decompose. There is a lot of types for plastic, and it goes through a long process. It affects the environment negatively. However, it's a helpful material for us. And then we have the resources. Thank you for watching.